Fuel injection. Fuel in a liquid state is injected into the cylinder at a precise time and rate to ensure that the combustion pressure is forced on the piston neither too early nor too late. The fuel enters the cylinder where the heated compressed air is present. However, it will only burn when it is in a vaporized state, attained through the addition of heat to cause vaporization, and intimately mixed with a supply of oxygen. The first minute droplets of fuel enter the combustion chamber and are quickly vaporized. The vaporization of the fuel causes the air surrounding the fuel to cool, and it requires time for the air to reheat sufficiently to ignite the vaporized fuel. But once ignition has started, the additional heat from combustion helps to further vaporize the new fuel entering the chamber, as long as oxygen is present. Fuel injection starts at 28 degrees before top dead center and ends at 3 degrees after top dead center. Therefore, fuel is injected for a duration of 31 degrees. What's interesting to notice here is that fuel is injected 28 degrees before top dead center. Now that is quite surprising, because if we inject the fuel before top dead center and it starts to combust, then realistically we're going to push the piston back in the opposite direction to the direction that we want it to go. So it's only the momentum of the piston that gets it past top dead center and then allows it to move back down the opposite side, in other words in a clockwards direction, when the fuel has combusted. If the fuel combusts too early, then all of our power stroke is going to be used to drive the piston the wrong way. But what actually happens is the other pistons and the weight of the engine components, which are already in motion, will push the piston towards top dead center and then back down again. Unfortunately, we didn't get much power out of this whole process, and we actually call this knocking. That's what happens when your engine is knocking. The fuel is combusting too early and you're wasting all of that power that you should be extracting and sending to the load. However, generally, if you inject the fuel before top dead center, by the time the piston has reached TDC, the fuel would just start to ignite, or shortly before, about 5 degrees before TDC, the fuel will suddenly combust and all of that power will then be transferred to the piston as it rotates back downwards towards bottom dead center. So we're not wasting any power. However, like I say, if it ignites too early, then we're going to get knocking, and all of that power that we should have extracted and sent to the load is going to be wasted. What's also interesting is as we inject the fuel, what's actually occurring first is that we inject it, the fuel vaporizes, which means it changes state from a liquid to a vapor, and because of this change of state, we actually get a temperature drop. And this is what allows us to inject the fuel at 28 degrees before top dead center. We get a short cooling effect as the fuel is vaporized, but then obviously the fuel combusts and it makes combustion of the other fuel entering into the combustion space a lot more efficient and quicker. And all of that is happening in literally a fraction of a second. So 28 degrees, fuel injection starts. The initial amount of fuel that's injected is vaporized. That cools down the surrounding area slightly for a fraction of a second. Then it combusts the fuel. Then the remaining fuel that is injected also combusts. And by the time we get to 3 degrees after top dead center, we're then having the explosion. It's well underway and we're pushing our piston down and we're beginning our power stroke. The total fuel injection period is only 31 degrees in total. So it's a very short part of the 4-stroke cycle. Literally only about 4 or 5% of the entire 4-stroke cycle.